This is a video for AQA Mechanics. This is Impulse and Momentum section 1.1, where we're introducing the idea of momentum. Momentum is a quantity that depends on both the mass and the velocity of an object. In fact, it's defined as being the product of the mass and the velocity. We can consider the units of mass. They are kilograms, and velocity meters per second. So we could have the units kilograms meters per second. However, it's more usual to use the units of Newton second, which is a force multiplied by time. So we get a Newton second as being the units. Notice that velocity is a vector quantity, and therefore the momentum must also be a vector, so it has not just magnitude but also direction associated with it. Change in momentum, which is something we'll be considering in these and later videos with collisions, is defined as being the final momentum minus the initial momentum. Notice that momentum is not the same as energy. Let's just consider then finding the momentum of a couple of different objects. So here we have a speedboat, mass 270 kilograms, moving at 30 meters per second, and a steamroller 5.4 tons moving at 1.5 meters per second. Remember that momentum is mass multiplied by velocity, so for the boat we have then the momentum is equal to 270 multiplied by 30. That comes out to be 8,100 Newton seconds. On the other hand, the steamroller, that's 5.4 tons. Now we've got to work in SI units, so we need to convert that first of all to kilograms, so that's 5,400. And we're multiplying that by 1.5. And that again gives us 8,100 Newton seconds. So here you can see that both these objects have got the same momentum. One of them relatively small mass but large velocity, and the other one a very large mass but small velocity. They may have equal momentum, but they certainly won't have the same kinetic energy. Now let's consider a couple of examples where we're looking at the change in momentum. So first of all, we have a mass of 3 kilograms increasing its speed from 6 meters per second to 15 meters per second. So we want to work out the change in momentum. It's always a good idea to draw a diagram of these situations. So there we are, a before and after. And remember then that we said that the change in momentum was the final momentum minus the initial momentum. So if we look at the momentum afterwards, then we can see we've got 3 kilograms, the mass is 3, multiplied by 15, and we're subtracting from that mass multiplied by velocity beforehand, so we've got 3 multiplied by 6. So therefore we get 45 minus 18, which gives us 27 Newton seconds. Now this is a positive value, so in other words there's a change of 27 Newton seconds in the direction of motion. So in this next example then we've got the speed changing from 5 meters per second in one direction to 4 meters per second in the other direction. So if we put that onto a diagram, you can see we've got 5 going towards the right and 4 to the left. And when it comes to calculating the momentum, because it's a vector quantity, we need to define a positive direction. So in this particular question I'm going to take positive to the right in the direction of the initial motion. So now we can calculate the final momentum minus the initial momentum. But the final momentum will be a mass of 3 multiplied by velocity of negative 4, and then we're subtracting from that mass 3 multiplied by velocity 5. So negative 12 minus 15 gives us negative 27 Newton second. So this time, again, a change of 27 Newton seconds, but because of the negative, this is a change in the opposite direction to the initial motion. That's the end of this particular video looking at an introduction to momentum. In the next one, we'll be looking at the idea of impulse.